Good afternoon, everybody, or good day. Can I say better for all our audience? It's Lex again. We are here with another episode of Azure on Air. And as you could already see today, we have with us Ahmed Taha. Welcome to the episode, Ahmed. And before we move to the actual questions, let me do in the actual session. Let's do a short introduction about yourself. Well, according to LinkedIn, you are an Azure architect and an integration architect. That's nothing new, of course. And actually, you have moved a couple of years ago, right,
Yep.
from Egypt, your
Yeah.
native country, to the Netherlands. And currently, are you living in Amsterdam? I believe you have mentioned that.
Yeah. 2 years in Amsterdam, just moved a month back into The Hague. So close by, I would say.
Oh my God! Yeah. This really really short by to where I live. I
Yeah.
wasn't even aware of that. That's nice. Well, you should come over once then, right?
Yeah, absolutely.
Yeah,
Let's do it.
yeah, certainly. Yeah, certainly. Let's do that. Okay, that's good to know. That's indeed. Yeah, I wasn't aware of that. But well, yeah, the company that you work for is still the same. I assume that's Capgemini,
Yep.
one of the bigger consultancy companies, also here in the Netherlands, of course. And yeah, can you tell a little bit? How long have you been in integration? How long are you in Azure?
Yeah. So I've worked like a little over 16 years now, close to 17 years in integration and web technologies with Microsoft Tech Stack. Started with BizTalk, my preferred integration platform to the day. So I know that a lot about the controversies, but yeah, that's still my preferred integration platform. I also worked with like SSIS and reporting services as well as web technologies in general.
Yeah,
And I focused on maybe the integration architecture for the past 10 years now,
yeah.
and still is my focus to this day.
Or even longer, right? I mean, integration, Bistro clearly is also integration. So indeed, yeah, when you started using that around 14 years ago, well, we can easily add that up to your integration experience, right?
Yeah, absolutely. It
Yeah,
is the ultimate experience, I would say.
true. And there are just so many differences, right, between yeah, the Azure platform and the Azure integration services in, well, not necessarily stability, but yeah, uh, where BizTalk is much more static. You install everything, and the environment doesn't really move. Uh, Updates to your integrations itself, but the technology remains the same until you upgrade to BizTalk, of course, and that's just so different in with Azure. And well, I assume that will be one of the topics that you will be talking about in this very session.
Yeah.
Because yeah, today we're going to talk about building a robust Azure solutions. And let me add the slides here. Yeah, I would just say, yeah, just go ahead, Ahmed. Let's make this a nice conversation.
Yeah, nice. Thanks, Alex. So indeed, that's the today's topic, like how to design robust solutions on Azure. And this is based on a lot of readings, a lot of experience, a lot, many lessons learned, and interesting discussions with colleagues about this specific topic. So of course we start as usual with POCs for when we are trying out new technologies. But as you know, like POCs are just fragile solutions that prove the concept, but we need more production grade solutions. That is what is the topic of today, like how to build such robust solutions for production. So today I'm going to focus on just three operational aspects, uh, which is the solution being available for end user, of course, being resilient to transient failures, and also being performant and of good performance in general. Of course, the list, as with any list, it can go on and on. We can talk about security, testing, monitoring, disaster recovery, you name it. There are a lot of other aspects to that. But for today, I'm going to focus on these three operational aspects. And maybe we can have some discussion as well around it. So I think we need first to discuss why building robust solutions in the cloud and in Azure in specific, but generally in the cloud is more challenging than typical on-prem solutions. So again, like focusing from end user perspective, I'm sure we have all done online payments. We all try to do like buying shares from the stock market, or trying to do registration for an examination, for example. So the worst thing you want to see is an error message like the one that you see now. Something went wrong and you don't know what's happening, if your money has been already went through or not, if your examination, for example, has been registered or not. So this type of uncertainty, this type of issues can actually impact the trust level of end users. You don't want to see that, especially for critical applications. So going back to what makes it challenging for the cloud, let's go a little bit back to on-prem solutions. So on-prem solutions usually had multiple nodes, which can, by the way, scale to handle performance. But the main components were very limited, I would say, compared to cloud solutions. So you can have a web server, you can have an identity server, you can have a data store, you can have a middleware server, which each of these components can actually scale. But in a sense, you have total control over the underlying infrastructure. So the actual compute, the networking, the devices, the storage. So that level of control, once it's done at one time correctly, it becomes a very stable environment, given the performance that was anticipated at the beginning. And the technology itself was also somehow stable, like what we're talking about: platforms, operating systems, virtualization technologies, networking. All these components were really very stable. Yet still, this was considered a distributed architecture in a sense, because you have multiple nodes that cater for different concerns. You have middleware server somewhere, and you have web server in another place, and so on. But if you compare that to the cloud, now this is a highly distributed architecture, and this is by design. So the cloud itself is designed to have finer grained components. These are the services that you can see here. So it's a lot of moving parts for the system components, and you have to stitch them together so that you formulate an actual end-to-end solution. In addition to that, of course, we are offloading a lot of the responsibilities to the cloud provider, in this case, Microsoft. So if you look at that, just, I would say, very typical and simple solution, it's a lot of moving parts, right? And the abstraction that is provided, and this is the second thing that makes such cloud solutions more challenging, is that level of abstractions that is provided. So let's get into a quick example of from programming days. So I still do some programming here and there. And yeah, so when we had to call a remote procedure call, like a SOAP service or something, and do a simple operation, well, we will, using the IDE and using the programming languages, we were totally abstracted from the complexities that are happening behind the scenes, right? So we really didn't know much about how the serialization of the object is being done, how the actual realization of the communication protocols that's happening behind the scenes. What about the intermediate network components? What's happening on the server side? That's all abstracted from us. And that's for a good reason, like to make us more productive, to make us focus more on the actual code that we are trying to build. Yet this very same abstraction creates this trick for us that makes it a little bit tricky, because if you are a new programmer, you would see that as a local function, right? So you don't have to anticipate what could go wrong. Like, I'm calling a function, I'm getting a response back. But what happens behind the scenes is actually a lot. So there's stuff that's happening all the way to the server and back. And it's this type of complexity that's been hidden by simple abstraction here is what makes it very challenging when things go wrong. And this is when you get a little bit glimpse of the complexity level of such abstractions. So the same goes for the cloud. So again, we talked about on-premises, where we have total control over the tech stack all the way to the hardware. But let's focus on the platform as a service here. So again, these are fully managed services. You totally get abstracted from the underlying infrastructure, again, for a good reason of productivity and time to market and all that. But I think that you still need to understand about what is being offered there. So you need to get a little bit deeper into the offerings that is provided by the vendor. Whether it's that, what about the compute power of underlying technology? What about the storage, the IOPS, for example? What about the network capabilities, limitations, and even the behavior? And this is very critical when it comes to platform as a service, that you need to understand certain behaviors, good and bad. For example, Azure Functions with the cold starts, or API management with its throughput and latency, and how higher throughputs can impact latency, and you do that across testings. So that level of understanding you still need to have in order to build robust solutions. And because again, like these are hidden from you, so you need to understand a little bit about it. I always tell my colleagues, like, yeah, we don't see what's being abstracted there, but it doesn't mean it doesn't exist. So still, hardware is there, VMs are there, OS are there, but again, you don't have to dig that deep, but you need to go to a certain level of understanding. So moving parts and abstractions, I would say, are what makes it a bit challenging. So let's start with the first one about availability. So the key part here in availability usually is about redundancy. So in order to combat the challenges of having issues with a certain solution or a certain component, you can have it somewhere else. And this can be provided by Azure itself, for example. So some services provide this capability of natively supporting redundancy within a single region, such as through availability zones, for example. Some SKUs provide high availability, again, with the abstraction of the actual infrastructure that's hidden behind us. But some solutions that you do the replication yourself, the redundancy yourself. So this means that, for example, in this diagram, you can have a complete solution that is deployed in another region. So this means that we are now having availability across regions. So if a region-wide outage happens in a single region, you can actually control the traffic to move to the alternative region. So of course, a very important tip here, failovers and availability and redundancy, that never works in an instant. So there will be a little bit of hiccups happening during the failover and failback mechanisms. So no matter what technology or client components you're using, there will be some stop that will be happening, and just consider it as a transient issue that will be happening. And you need to detect that as soon as you can with the technology that you have and switch over to the active region. So, of course, in this particular scenario that you can see, front door here, Azure front door can do that routing of the traffic. But again, it's not instantaneous. It has health probes that's going to the endpoints, the public endpoints in the regions. And whenever it reaches a maximum threshold that you set, it will actually fail over. But again, after a few, maybe seconds of failures that can happen. So this means that even client applications that you see here need to be also aware of such hiccups that can happen, the transient failures, and we will talk about that in a little bit. We talked about availability zones here. It's again, this is part of the native capabilities of the services, which can provide such redundancy in a single region. And we have something also called the global services like front door or Azure Active Directory. That's by default, it is actually global, and it has a lot of points of presence across regions, and that provides the availability required. Before we move to the other point, I would like to focus on the availability SLAs and give some pointers here about it. First of all, I think it's very good to map those to numbers so you can see that, okay, when we talk about 3 nines, 4 nines availability, what does it mean in terms of downtime per unit time? So you can see that, okay, that downtime per week is 6 seconds. This creates a good discussion with the business stakeholders so they can understand the impact to be expected from such SLAs. Because if you talk about four nines, 5 nines, 3 nines, that's a bit vague. The second point also that is SLAs are not guarantees. So that's what cloud providers strive to achieve. And it is based on contractual agreements that these SLAs will be provided. There are compensations somehow, whether through credits, discounts, or so on. But again, we need to understand that it's not 100% guarantee that these numbers will be achieved. The last point I want to mention here is that by achieving higher SLAs, it is entailing a lot of complexity to the solution and a lot of cost. So it gets really quite expensive to achieve higher SLAs. Another point to mention about composite SLAs. So the previous slide when we talked about SLAs, it's mainly about a single component within the system. But when you start to build multiple components, you can have what's called a composite SLA. So you can have a web app, for example, and in the back end you have a data store, which is Azure SQL, let's say. The combination of those is actually the overall SLA of the entire solution. So it makes sense, of course, that if you have a lower SLA for the web app, which is part of your solution, then this will be the SLA for the entire solution, because this is the probability of the solution going down because of a single component going down.
Exactly.
And
yeah, that's the weakest link, right? So that makes
exactly,
sense.
exactly that. And in the link that you can see here, I just put it in the slide, you can understand how it's calculated in mathematical formulas, but as you said, it makes sense. It's the weakest link of the solution. So it makes sense that the overall solution will have such an SLA. But you can see here if it is having multiple paths, so you can have the web app either going through SQL or through a queue. This actually increases the SLA of availability of the SLA for these two components only. So you see that how redundancy can actually boost your SLA. Still, the end-to-end SLA is as low as the single component that has not been redundant, but you can see how this actually makes sense. You're right. It's also good to know that not all flows are the same. So, for example, in a very complicated solutions, you don't have to do that for the entire component. So if there is a critical flow that you want to focus on, for example, related to payments, related to transactions, all sort of critical paths, you can actually focus on that alone without having to do it for the entire solution. Yeah, so also with multi-regions you can do that, but it's very tricky here as well. Like there is a formula for the multi-region part as well. Again, it gets very higher in terms of SLAs when you have multiple regions. But remember that once you go to a single region, you still have the same availability that was already there. So from a client side, like even before reaching to the routing mechanism that will route you to which region, you have that high SLA. But once you reach a region, you go back to these lower SLAs. And of course, the routing mechanism and the routing service, even the client, will need to be as available as these SLAs as well. Otherwise, again, it creates another weak link.
Yeah.
Yeah, so the second part is about fault tolerance and how to make your solution as resilient to transient failures. Again, we are not here going to deep dive into disaster recovery or any other stuff that is focused on that, but we are focusing here on the transient failures between the different components. So because again we are having distributed components, uh, we have a lot of possible failure points here. So the question becomes how to recover from transient failures gracefully and as much as possible transparently from the clients or client applications. But here we get a lot of important questions. Is it in case of failures, can we do retries actually from a business perspective or not? Is it allowed or not? If the backend systems that we are integrated with is actually allowing safe operations such as get operations that will not change the state of the application, or does it provide operations that can change the state of the operations, which is the unsafe operations? And if it is changing the state, is it an idempotent type of operation, which means that it will not change the state with the retries, or do we have to handle that ourselves and prevent such an effect? So state can actually complicate things with all the three operations aspects that we talked about so far, especially with the retries and fault tolerance here. And also in terms of handling exceptions. And we want, okay, an issue happened, a fault happened. We want to make sure that the system is brought back to a consistent state, especially when we have multiple data stores that's outside of our control, or inside our control. Then we go to the topics of distributed transactions and how to compensate and try to get back to a consistent state. So a lot of thought have to be done before we design such applications. Of course, this is a very extreme case when we are moving from POCs. When POCs, we are not expecting any issues, although it happens sometimes as well during demos and POCs, but still, that's how the difference or the shift in mindset that you have to think about all these concerns. Another thing about the fault tolerance part is that when you have this chain of dependencies, you need also to think about, okay, let's say that we are allowing retries to happen. Retry mechanisms can be achieved with built-in functions such as those provided with Azure API management policies. Logic app connectors can provide such functionality of retries as well built in. But the question becomes, who will be in the driving seat of the retries? Who will control these retries? You don't want all these components to do unlimited number of retries. You have to control it. You have to think about which component will be in the driving seat of such retry logic. Of course, exception handling, as I said, we need to, after retries and we reached the end of it, we need to handle the exception properly. Sometimes we have to decide whether to fail fast and skip the retries altogether and just immediately and promptly inform the client or client application about it and bring the system back to a consistent state. Of course, if it is a system integrations, usually retries can be tolerated. But if it's end user is waiting on the other side, it's usually either very fast type of retry just to skip a transient error, if that's possible. Otherwise, we will have to fail fast. But importantly also that a lot of times we focus on our solution, which is, let's say, this is the one in the blue box here. But it is an end-to-end responsibility to have a fault-tolerant solution, even with your client application that are consuming your services or your back-end systems. Now, these can be outside of your control. So these can be systems from vendors, from other parties that you're integrating with, client application the same. So it is an end-to-end responsibility. In my opinion, it takes a lot of collaborations with the different teams to design the entire system as being fault tolerant. So let's
Exactly.
say, yeah, exactly. So let's say a network issue happened. So it doesn't necessarily have to be our solution that's failing. A network transient failure happened between the client, wherever they are, and our solution. Then the client will need to do a little bit of a retry whenever possible, and again report errors immediately if that's the case.
Yeah.
So this works only if we collaborate with these client applications, and it takes a lot of time and effort just to do, I would say, a coherent solution from a fault tolerance perspective.
Yeah.
So it feels the same, like we are a part of the chain, but we are not the whole chain.
No. Yeah. Yeah. It's really part of the design, right? And really thinking about all the different, yeah, areas where things can go wrong anyway, and what time, what moments you can still do some kind of compensation, and what moments it's not possible because other parts of the integration might have already been successfully be completed. So it can be really complex, right?
Yep, and it takes a lot of politics as well. Like sometimes who has the upper hand to control the architecture end to end. It's a lot of communication, a lot of collaboration, but at the end, it works well when there is consensus about how to handle exceptions. And here we're talking about the transient failures, especially. Again, not all flows are of equal importance, I would say. Same with the availability part. So it depends on the criticality of the path or even the entire solution. You need to look at that and assess that, because again, it adds a lot of complexity to the solution and adds more time and effort and collaboration and all these type of challenges. Um, yeah, third part is the performance part, and I would say scaling is the main feature within performance on the cloud. So it is in a sense a redundancy in an active and active manner, but it's built in within the services that are available. For example, with web apps here, it's good to know that when you're selecting certain services or service offerings from Microsoft, um, let's say take Cosmos DB for example. These are a special service that has a very low latencies and high throughput by design. So selecting the right services in this case can actually achieve the performance requirements that you want to achieve. So that's based on the underlying capabilities by certain SKUs. For example, with Azure SQL, you have the business critical SKU for the vCore model, which actually have higher IOPS in this case. So again, depending on what you're looking for, this is the type of understanding of what's being offered in terms of the alternatives and service offerings by the cloud provider. Performance also, we talked a little bit about the intricate details about behaviors that you need to be aware of. We talked about the Azure function with the cold starts and the serverless model. We talked about API management with the throughput latency type of measurements that you would need to understand and inspect, and even network part. So I, from like maybe I think 5 years ago, most of the PaaS services were public by design. And when Microsoft introduced the concept of service endpoints and later the private link endpoints, that meant for more secure network traffic. But also it has an impact on performance because the traffic will be going through Microsoft backbone rather than the public internet. So if you have a web app that's going to a data store in Azure SQL or Cosmos DB that is totally public, this actually by default the traffic will go through the public internet and all the way back to your solution for the Azure SQL or Cosmos DB. So using PLEs, for example, or private link endpoints can actually achieve such performance. So even the network setups and how you do it and how the peering is done, for example, the selection of the technologies and setups for example, hybrid integrations as well can impact your performance. Of course, there are additional techniques to achieve performance, such as caching here, whether it's server-side caching or web static content caching, like using CDNs, which can improve the application throughput and latency, or at least the perceived performance from end users.
Yeah. Yeah, and even also the kind of network that you would choose, right? And the bandwidth that you purchase. This is just so important. I've seen customers here with part of their IT in the cloud, while still other stuff is still on premise, where there was a lot of messaging going on. And initially, well, the calculation for having the correct bandwidth, the required bandwidth, yeah, was not done correctly, or at least it wasn't sufficient. Yeah, and well, yeah, they just start with struggling with the actual performance, but after that, you also need to deal with higher yeah, budgeting, because you need more network, which is clearly more expensive than you yeah, initially anticipated for.
Yep, and it gets more challenging even beyond the hybrid as well.
Yeah,
Imagine like you having multiple tiers of network within hub and spoke, for example, topology, and then now you have multiple network hops, and if it is intercepted by firewalls or WAF application, now we have even more network hops and even more latency introduced. It can get quite interesting and complicated with the additional components and complexity, I would say.
sure.
But indeed, like it takes a lot of time and a little bit of experimentation as well, I would say.
Certainly. Yeah, certainly. Yeah.
So maybe a few tips here about the performance as well. Um, I would say take care of the mismatched scalability for the different components. I've seen it a lot where web apps can scale, or maybe Azure functions with the serverless can actually scale to a high extent, while the backend cannot actually cope with this scale. So the type of mismatch between the capabilities for performance, for example, can actually impact your solution availability as well. Um, there are again performance latency degradations techniques where like that could happen for certain services. So with higher throughputs, latency can be impacted. I've seen it with multiple services. One of them was API management in some cases, in some regions as well. So you need to take care of those. Again, part of the behavior of these services. And also, of course, using the wrong service or technology can also impact performance. So if you need to use a NoSQL data store, and you need very low latency, like single digit milliseconds of latency and very high throughput, and you chose something else other than Cosmos DB, then you probably will performance will be impacted as well. I've seen, for example, one use case when one web application required real-time communication for returning results from matches or games, or like soccer. And during high events, like whenever there is an actual football matches that's happening, part of a league or something, the site went down. And the reason for that they were using, for example, normal communication like HTTP request for each and every change in results or commentary that's happening. So real-time communication such as Signal R, for example, was the proper technology. While not using that, they suffered a lot. So what they ended up doing is that let's scale out the web apps or the API apps in that case.
Hmm.
So even though that survived a little bit, made them a little bit survive for some time, but still it didn't perform because the demand is still increasing and you're using the wrong technology in the first
Exactly.
place.
Yeah, yeah. So that is a design issue, right?
Exactly.
Yeah. But that also comes down with the skills of the actual architects, because well, you need to be aware of all those different technologies, and
Yep.
yeah, what technologies you would be using the best in what scenario.
Yep.
That can be complex anyway, right? Because well, yeah, upfront you can't always tell what exact scenarios, yeah, will happen, and that's well, it doesn't make things easier, of course.
True, true. And I always like to separate these two things, like the skills of the team and what are the alternatives or the options that can, from a technological side, can work.
Yeah,
So at least I present those as an architect, and it's up to the organization to actually either find the skill or understand and accept the risk.
yeah,
So
yeah,
so maybe the last thing I wanted to talk about as well is the impact between the different operational concerns. Um, so by thinking of, again, this is not comprehensive, but like by thinking about these three concerns alone, um, it to achieve them, it adds more complexity to the solution design. So it impacts the structure of your solution. It adds more components. As we saw, maybe multiple regions are being employed. Maybe more expensive services are being deployed, or as you said, like maybe new technologies is being adopted, and we need to train our teams.
yeah,
So all these concerns are actually adds complexity, but they also can impact each other. Like for example, performance. If you have a low performance application, this means that it might not be available for some users who are uh, using your service, for example. The same goes with resilience. If the solution is not resilient enough, that means that it will not be as available. So this interaction between the concerns can also happen. My advice here is to focus on what is really important, understand the context, understand with the business stakeholders, try to align with them, uh, quantify as much as you can in terms of expectations like performance, page load times, stuff that is really can be tangible and quantified as much as you can. SLAs, as we saw, needs to be quantified and mapped to downtime so we can see the impact to be expected. But there's also the solution part. So we talked about this from an infrastructure aspect to the main part, but the solution itself, your solution with its design, the configuration, its own logic can also impact these concerns. So your infrastructure would be there and available and doing the proper performance and resilience, but your solution itself can actually lower those concerns as well. So you need to make sure that it is designed properly, its logic and configurations, even the selection of the technology and services can be actually aligned with the requirements in terms of the performance, availability, and resilience. Uh, One final thing. So to recap, yeah, just try to go behind abstractions. Try to understand what's being offered. So don't dive too deep, but at least understand what's being offered, understand the alternative, understand um, the trade-offs, and also design with moving parts in mind. Just understand that these are distributed components. You need to understand what can go wrong from a stateful perspective and also a status perspective, but put these two things in mind.
yeah. Yeah, and yeah, especially one of those areas where developing solutions in the Azure cloud is just different compared to how we did it with BizTalk, right? I mean, a BizTalk environment is a static thing, and meanwhile in Azure, well, there might be updates to logic apps or other components. Which probably are not going to impact your solution, but you never know, right? Always something unexpected might happen. And
Yep.
clearly, yeah, the more components you have, the more risks there are that something breaks.
Yeah, exactly. And it's always moving targets. So you actually it's always continuously evolving, and you need to keep up. And that's part of understanding what's happening behind the scenes, always trying to keep up with the updates from these service offerings. Yeah,
Yeah.
indeed.
Yeah. True. Yeah. True. 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 Yeah. Okay. Oh, thank you, Ahmed. This was really nice.
Thanks.
So I go back to this screen. Oh, did I do it correctly? No, I don't think so. This one. Yeah. Okay. There we are again. Yeah. No. Yeah. Very nice. Yeah. Thank you so much. I had a couple of other questions, not directly related to your topic, but more to understand a little bit about well the areas there where you would go to. Both actually, yeah, is Natalie here in Netherlands for gaining knowledge, and maybe specific youth groups. Yeah. What would you normally do? Where do you get your knowledge?
Yeah, so mainly I concentrate on books first. So reading books is my number one, I would say. I still consider it number one, um, because you get like a distilled type of experiences and knowledge from the industry gurus in the field.
Yeah.
That's the main source. Of course, attending conferences. There are lots of conferences in the Netherlands here, so that's a good part of it.
Yeah.
Yeah, I attend lots of conferences. Of course, whether it's Integrate, Azure Lowlands as well is very popular here. Azure Fest as well in the Netherlands.
Yeah.
But I also like to focus on the architecture. So any architectural conferences as well, I like to attend those, whether it's virtual or in person indeed. So I think these are two main uh, sources I would use for gaining knowledge.
Yeah. 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 So both analog as well as digital.
Yep, indeed.
Yeah. Nice, nice, nice. Okay, maybe as a last one. Well, yeah, you have been with us a couple of times, and of course, we are always looking for other people who want to join us as well for episodes. Can you think of maybe somebody who would be interested, yeah, to tell a story? Yeah, something, maybe somebody who has an interesting story, or maybe a specific topic you would be interested to hear about.
Yeah, I think I have an interesting topic that I would like to hear about is, which is, yeah, maybe I touched on that in my slides. It's about distributed transactions and how this can be achieved on Azure properly.
Yeah, yeah,
It get quite challenging, to be honest. In certain use cases where it's very critical to have consistency across, uh, yeah, across the multiple data stores, and how this can be achieved with all the moving parts, as I said. So I think, yeah, that would be an interesting topic. I'm not sure who can do that, but I'm sure that someone has the ultimate experience for this.
yeah. So you're really talking about the asset principles, right? Uh,
Exactly. In
uh,
this
but
case, yeah, or let's say here the base principles.
yeah, yeah,
Yep,
yeah. No, that's fine. We can check indeed. Well, yeah, we have a huge network, of course. So maybe we can find something who can talk about it. Yeah. No, okay. Well, that would be interesting. Okay. Well, thanks, Ahmed.
thanks.
Well, nice to know indeed, yeah, that you live so close by. But at least we will also meet at Integrate in London, which is happening in not much more than a week actually. So that will be very interesting as well. As you know, the conference this time it's only 2 days, but well, yeah, we have added so many interesting sessions. So I think people will still benefit of all knowledge that is shared. Uh, Besides the ability, yeah, to speak to colleagues and directly speak to people from the Microsoft product groups. So yeah, we are looking very much forward to the conference. I assume that you will do the same because, well, yeah, you are also a frequent visitor of the conference.
Yeah, true.
Yeah.
Thank you very much, Lex, for inviting me to this call.
Yeah.
And yeah, I look forward to meeting you in Integrate.
Okay. Yeah. Well, fantastic, and that will surely happen. Okay. Well, thanks everybody, and we will see you in the next one. Okay. Take care.